Hello, good morning. And in today's class of digital circuits, we are going to see about the combinational circuits. Under the combinational circuit, the parity generator and checker. This is the topic we are going to discuss today. So, what is mean by the parity generator and parity checker is nothing but it checks the parity bits. Based on that, it will be either generated or checked. Okay, so parity generator technique is one of the most widely used for error correction and techniques in digital system. When a binary data is transmitted and processed, data may be subjected to noise. Okay, so in order to remove the noise will be in the form of zeros and ones. That is, the noise in means ones are changed to zeros and zeros are changed to ones. So simply says that so in order to correct the errors, we are using this parity generator techniques. Okay, so what this parity generator will do is it's a combinational circuit that generates the parity bit in the transmitter. On the other hand, the circuit checks the parity bit in the receiver. We call as a parity checker. So in the transmitter side, we will use the parity generator, and the receiver side it is used as a parity checker. Okay, so normally the parity generator and checker is divided into two types: even parity bit scheme and odd parity bit scheme. Okay, so in even parity bit scheme, the parity bit is 0. That means if there are even number of ones in the data stream, and the parity bit is 1 if there are odd number of ones in the data stream. Similarly, in odd parity schemes, the parity bit is 1 if there are even number of ones. Okay, if the input data is contains even number of ones, the parity generator or odd parity generator will generate 1 in the generator, and it will add with the data stream. Okay, so if the data stream contains odd number of ones, then it will add 0 to the input. So this is the simple concept. You can see this truth table so that you can easily understand. So it is a even parity generator. So if the number of ones is odd, then it will generate 1 in the output. Otherwise it will add 0 in the generator. So for example, first the A, B, C, or the truth table, the A, B, C is the inputs, and the Y is the parity generator output. So if the input bit is 0, 0, 0, all threes are 0, then it will generate 0 only. So if the input is 0, 0, 1, that means it contains odd number of ones, because the C input only having the data input 1. So the even parity bit generator will generate 1 at the output. So it makes the numbers as a even, and then it will transmit to the channel. Okay, so in the, for example, similarly 0, 1, 0, it generates 1. And the next condition is 0, 1, 1. B input and C input is 1. That means it contains odd number, even number of ones. So it produces 0 output. So look at the last table. The 1, 1, 1 is a odd number of ones we have in the data inputs A, B, C. So it generates. In order to convert this into even, we have to add one more 1 at the output. So 1, 1, 1. For that, output will be 1. So if you add all the 4 data 1, 1, 1, 1, it remains even. So now odd is changed to even. So if the input number bits are A, B, C, if the input bits are odd, then we have to convert into even. That's all. That's the concept. Okay. So for that, we have drawn the truth table and logic diagram and the truth K map. Okay. Similarly, if you go look at the odd parity generator, here also the inputs are A, B, C, and the output is Y. The input is 0, 0, 0, means the number of ones is 0 here. So we have to convert this data stream into the odd terms. So we are adding 1 to this. Look at the last term, 1, 1, 1. This is odd. So the same can be transmitted. This odd number of ones only presented here in last condition of the truth table. So we have to generate 0. So if you add all 4 these things, 1, 1, 1, 0. This is the bits we are going to transmit in the channel. Okay. For that also we have K-map and logic diagram. Now we are into the receiver side, that is a checker, a parity checker. So the received input contains data stream plus your parity bit generated output. So look at the truth table, the 4-bit received message. ABC are the actual message received from this source, and P is the parity bit generator. So combiningly we are receiving this as an input for the receiver side. So the receiver will check whether the data streams contains odd or even. If it is odd, then it produces the output 0. That means there is no error in this output. So if the parity check CP, the last column is 1, means that the input data contains error, otherwise the input is not having any error. So first condition is 0 0 0 0, all the 4 inputs are 0, so there is no odd number of 1, so we are producing 1 as a output. That means the data contains error. Second one, data is 0 0 0 1. A, B, C, all threes are 0, P is 1. So in a 4-bit message 0 0 0 1, it contains odd number of ones. That means there is no error in this bit. If you take last input 1 1 1 1, okay, that means 4 number of ones. That means you have 4 number of 1 means you have an even number of ones. So that means there is an error in there, because it is an odd parity checker. Odd parity checker will check only whether the odd number of ones is received or not. If it is not received, then it produces the error signal. Okay. Similarly, go for the even parity checker. This even parity checker will check whether the received signal has an even number of ones or not. If it is not, that it will produce the error signal. Okay, so take this as assignment. What is parity bit? Difference between the odd and even parity bit, and you can design a parity generator of 3-bit odd parity generator using. Okay, so this is take as an assessment. So we can bring out your answers and we can discuss in the next classes. Okay, thank you.